All right, we'll get started. Good afternoon. My name is Madhu Khanna. I'm the Interim Director of the Institute for Sustainability, Energy and Environment, or IC for short, at the University of Illinois at Urbana-Champaign. It is my great pleasure to welcome you all to this public lecture today. This has been made possible by a generous gift from the Alvin H. Baum Family Fund, which is led by Joel Friedman and Erica Cornelissen. The fund is the founding benefactor of our institute and continues to generously support IC initiatives like this one. The Baum Family Fund is committed to bettering the lives of people through health, human services, education, housing, environmental issues, and the arts, and we greatly appreciate their support. Our institute was founded in 2013 with a mission of actionable research, that is to bring together multidisciplinary minds to explore the wicked sustainability, energy, and environmental problems that are facing the world now and in the future. Another IC mission is to generate critical thinking and productive conversations about these issues. We regularly bring national and international scientists, activists, policymakers, and others to the UFI campus to provoke thoughtful discourse. And today is no different as we discuss how US energy policies need to catch up with the reality of human caused climate change. I'm very pleased to welcome our speaker today, Dr. James Hansen, who is an internationally known expert in global climate change and energy policy. Dr. Hansen is the director of Columbia University's Climate Science Awareness and Solutions Program. He's a longtime climate advocate and is perhaps best known for his testimony on climate change to the congressional committees in the 1980s that helped to raise broad awareness of the global warming issue. He was formerly the director of the NASA Goddard Institute for Space Studies. Dr. Hansen was trained in physics and astronomy in the space science program. His early research on the clouds of Venus helped identify their composition as sulfuric acid. Since the late 1970s, he has focused his research on Earth's climate, especially human-made climate change. He was elected to the National Academy of Sciences in 1995 and was designated by Time magazine in 2006 as one of the 100 most influential people on Earth. Dr. Hansen is recognized for identifying ineffectual policies as greenwash and for outlining actions that the public must take to protect the future of life on our planet. In addition to directing the climate program for Columbia's Earth Institute, he's also the adjunct professor in the Department of Earth and Environmental Science. His talk today is titled Global Climate Change, Implications for National and Global Energy Policies. And he will explore the history of the scientific and engineering community's failure to affect energy policies in ways that could have minimized climate change. He'll also look at how it can be done now and in the future to help address these problems. Really delighted to have him with us. Please join me in welcoming Dr. Hansen. Dr. Hansen, you're ready to go.
Thanks very much. And thanks for the opportunity to talk about climate change and its implications for energy policies. The challenge that we face is not new. The challenge has always been, how can we achieve prosperity without causing other problems? Prosperity always gets first priority. And that usually works out fine. If the energy sources cause a mess, air pollution, water pollution, we figure out a way to clean up the mess later. But climate change has created a new situation. The delayed response of the climate system creates a danger that we could leave young people a mess that they can't clean up, a situation that's running out of their control. So we need to understand climate change and choose our energy policies carefully. The Industrial Revolution, which raised living standards in much of the West, was powered entirely by coal for more than a century. In the 20th century, oil and gas joined in, and people's lives were transformed. 1 gallon of gasoline, that's 3.7 liters, contains the work equivalent of 400 hours labor by a healthy adult. Fossil fuels are remarkable condensed energy. They raised living standards in much of the world. Fossil fuels, coal, oil, and gas, provide most global energy today, and fossil fuel use is still growing. The clean, carbon-free energies are nuclear, hydroelectric, and most renewables. Governments give huge subsidies to renewable energies, the green area. But renewables have not even stopped the growth of fossil fuels, let alone caused their phase out. Fossil fuels are the main source of CO2 emissions, the graph on the right. Emissions now exceed 10 gigatons, 10 billion tons of carbon per year. So as a result, CO2 is increasing. It's now well over 400 ppm, parts per million, higher than it has been in millions of years. The growth rate of CO2, the graph on the right, is not declining. It's increasing. It now averages about 2.5 ppm per year. Methane is the second most important human-made greenhouse gas. Its effective climate forcing is about half as large as that of CO2. Methane had almost stopped growing 15 years ago, but now its growth is resurging, in large part because of the increased use of gas as fuel, with leakage from pipelines and at mining sites, especially from fracking, which pollutes groundwater and releases methane and CO2. So the world is getting warmer. It's about 1.2 degrees Celsius warmer than 100 years ago. Warming will continue the next few decades because Earth is out of energy balance. There's more energy coming in from the sun than going out as heat radiation. How much more Earth warms depends upon the changes that we make to our energy systems during the next few decades. The single biggest threat that global warming poses is sea level rise. Atmospheric CO2 is now close to the CO2 amount in the early Pliocene, a few million years ago, when sea level reached 15 to 25 meters higher than today. We can't allow that to happen. The US would lose all its East Coast cities, the state of Florida, and China is equally threatened. Beijing would survive a 6-meter sea level rise, even 25 meters, and it would gain some beachfront property. Shanghai is not so fortunate. A 6-meter sea level rise makes Shanghai a small island. China has a few 100 million people living near sea level. These are all of the world's largest cities. More than half of them are on coastlines. Cities would become dysfunctional long before they were totally underwater. So we cannot allow a sea level rise of several meters. The effects would be irreversible on any time scale that we care about. Global sea level rise so far is small, about 200 millimeters, 20 centimeters, or 8 inches. However, the rate of sea level rise more than doubled twice in the past century. And this rate could rise exponentially. Paleoclimate data imply that when an ice sheet becomes vulnerable to collapse, the disintegration is exponential, with a doubling time of no more than 1 to 2 decades. So we need to keep our eyes on Greenland and Antarctic ice sheets, especially West Antarctica. The Greenland and Antarctic ice sheets are losing mass now at increasing rates. Gravity satellites are measuring changes in the masses of the ice sheets. The best exponential fit to these short records have doubling times of 12 years for Greenland and 10 years for Antarctica. The data are too variable and too brief for conclusions, but if the doubling time is that short, and if greenhouse gases continue to increase, we will lose our coastal cities this century, while today's young people are still alive. The other irreversible climate impact is extermination of species. We cause stress on other species in many ways as we take over the planet. If fossil fuel emissions keep growing, climate zones will continue to shift, and we could commit a large fraction of species to extinction. Climate extremes are already increasing. The bell curve that describes natural climate variability last century is shifting. Relative to the climate of last century, climate is becoming more variable. What was an extreme hot season last century is now much more likely to occur. The shift is largest in dry subtropics in summer. For example, the Southwest United States, the Mediterranean, and the Middle East. The shift is also noticeable in tropical regions. Many low latitude regions are becoming uncomfortably hot, more difficult to work outdoors. Most non-household jobs are outside, agriculture or construction. The upshot of the shifting bell curves is an increase of climate extremes. At times and places where it is dry, there's greater heat, drought, and longer fire seasons. But warm air holds more water, so wet regions and rainy seasons can have more extreme rain and floods. The 100-year flood now occurs more than once a century. And storms driven by latent energy in water vapor and by ocean temperature, and that's thunderstorms, tornadoes, hurricanes, typhoons, they all have the potential to be stronger. Higher temperatures are observed to increase conflicts and violence. The largest effects of warming may be at low latitudes, but there are growing effects at higher latitudes. For example, the ranges of disease vectors, such as ticks and mosquitoes, are expanding. But never fear, it turns out that we must stop this shifting of climate zones and reverse it back to a climate that's a bit cooler than today. And how do I know that? Because we cannot allow the loss of all coastal cities. And to preserve these shorelines on the long run, we must go back to a world that's no warmer than the middle of the 21st century, middle of the 20th century, perhaps a bit cooler. Climate zones need to shift back more like what they were last century. As these facts become clear, China and the United States must work together, or they will sink together. China's emissions increased in the past decade and are now more than double those of the United States. However, it has been shown that global warming is accurately proportional to cumulative emissions. And the United States has the greatest cumulative emissions and is most responsible for global warming. The comparison is even more stark on a per capita basis. The West burned most of the global carbon budget. If China and India follow the path of Western nations, the entire world is in trouble. So we must work together to avoid that. Global energy use will continue to rise. The only way we can solve the climate problem is to reduce the carbon intensity, the carbon per unit energy. And we must reduce it to near zero over the next several decades. And we know how to do that. Sweden provides a good example. In the mid-1970s, it began to build 10 nuclear power plants, producing nearly carbon-free electricity. Sweden even uses electricity for heating. When they also use electricity to make transportation fuels, they will be almost there. High temperature industrial processes can be hydrogen enabled or employ modern nuclear power that produces higher temperatures. But the world as a whole is not doing a good job of reducing carbon intensity, as you can see on this graph. The small improvement in global carbon intensity is more than offset by increasing energy consumption. So emissions are increasing. We need all the carbon-free energies, and that certainly includes modern nuclear power. How did we get into this situation? Amory Lovins is the recognized leading global thinker on energy. He advised governments and industry worldwide, and he has received every prize imaginable. Amory visited our institute in the 1970s, and I was impressed by his knowledge of energy efficiency, its potential to reduce energy demands. He's a persuasive salesman. He was advisor to Arkansas Governor Bill Clinton and continued to advise President Clinton and Al Gore. Amory says we do not need any fossil fuel, oil, gas, or coal. We do not need large hydro, nuclear power, or a carbon tax. So is it any wonder that he is popular? Liberals bought into Lovin's energy strategy, hook, line, and sinker. And by the way, I am not a Democrat or a Republican. I'm a registered independent in the state of Pennsylvania, where I now live. So I began to make graphs of the energy story in the United States. I found that Lovins was partly right. Our energy use did not grow as fast as the government's Energy Information Agency predicted. It grew only from 70 to 100 quadrillion BTUs per year. But that was partly because much of our manufacturing went to Mexico, China, and elsewhere. However, Lovin's plan was that soft renewables would grow the dashed dot line and entirely phase out fossil fuel use by 2025. So it should be green up to the dashed dot line, but the absolute renewable growth is small, and half of the green is large hydro. The crucial requirement to solve the climate problem while also addressing population and human health is abundant, clean, carbon-free energy. The energy system must be economic relative to coal and gas, including costs of energy storage and any added transmission lines. However, nuclear power will be the complement to renewable energy only if its cost is below that of fossil fuels. That will require mass manufacture and product type licensing. Modern nuclear power plants must be passively safe, shutting down without human intervention in case of an anomaly such as an earthquake, and cooling the fuel without external power. The public must be involved and honestly informed. It will not be easy. We must expose the role of the liberal media and Big Green, the environmental organizations, which are partly supported by the fossil fuel and renewable industries. Consider the enormous issue that is raised about nuclear waste. Nuclear waste is stored in containers where it harms nobody. It can be used as fuel for future advanced nuclear reactors, which will reduce the volume of waste somewhat further. Let's compare this waste with that of alternative energies. Fossil fuels come with several costs. One cost is air pollution. The World Health Organization estimates that 3.7 million people per year die from outdoor air pollution, and another 3.7 million from indoor air pollution. Many of the deaths from air pollution, like those from smoking, are prolonged and painful to the victim and the family. Moreover, hundreds of millions of people suffer health effects short of death. Aerosols that people breathe are tiny. They enter the bloodstream, causing cardiac and respiratory problems. Not all air pollution is from fossil fuels, but a large fraction of it is. And there's water pollution. Groundwater is being contaminated, especially by fossil fuel mining activities, including fracking. I wish that all the public would read and understand this article that recently appeared in Science. Nobody in the public died from Fukushima radiation release. More than 1,000 people died because of the hysteria and the rushed evacuation. In comparison, more than 10,000 people per day are dying of air pollution, in large part from fossil fuels. Now, I'm not making light of the nuclear accident. It was a tragedy. The nuclear industry and the government deserve blame, and they have been excoriated. But at the same time, we must recognize that nuclear power has actually been among the safest energies over the past 50 years. And modern nuclear power has the potential to be much safer. Nuclear power also has the smallest environmental footprint of all the major energy sources. And there's enough nuclear fuel in the ocean to last forever. It's inexhaustible. And yet, the West is headed down the path toward gas plus renewables for electric power. And the East has a growing use of fossil fuels. So our young people and future generations are headed for disasters. The crucial underlying requirement to solve this problem is a rising price on carbon to make the fossil fuel price honest. However, we must have viable alternatives to fossil fuels. And that requires greater government support for research, development, and demonstration. It's easy to implement an across-the-board carbon fee, collecting it from fossil fuel companies at domestic mines and ports of entry. If 100% of this money is distributed equally to all legal residents, this yields a simple, transparent, market-based approach that spurs innovation. Wealthy people have a large carbon footprint, so they will lose money, but they can afford it. People will pay attention to the price of things on the shelf. Products that employ a lot of fossil fuel in their production will become more expensive. Economic studies show that this is the fastest way to phase down fossil fuel use. This fee and dividend spurs the economy, creates jobs, increases GNP, and increases government revenue. And fee and dividend is the one effective international approach. If the US and China adopt a carbon fee, we would both impose border duties on products from countries that do not have an equivalent carbon fee, which is a big incentive for other countries to adopt a carbon fee so they can collect the money themselves. A growing carbon fee is the main requirement to drive technology development and solve the climate problem. So how can we get emissions to decline rapidly while there are growing energy needs in emerging economies? And there's a need to break a huge fossil fuel addiction in the mature economies. Can China and the US really cooperate? No doubt they will continue to compete, but we must also cooperate. It's just common sense. We are in the same boat. We will either sink together or sail together. The choice should be easy. So let's encourage our governments. We love our planets and our children and grandchildren. We want them to inherit a remarkable planet, not an impending disaster. You know, we have friends, colleagues, former students in China. We should work with them on climate research and energy development. We can help lay groundwork for cooperation. We have had workshops with colleagues from China and India for that purpose. At one workshop, we concluded that one of the fastest ways to decarbonize energy is via construction of nuclear power plants. That's been true historically, and it could be true in the future. To do that in the future, I think we need product licensing and coordinated approvals and mass manufacturing. Nuclear energy has tremendous potential. If I were a young person today, I would choose nuclear engineering as a field of work. It's a profession with tremendous potential to help people to a better life and to help preserve the environment for us and for all species. My final chart is my address where you can find my publications and communications. And, you know, because of the way this talk turned out, it went very fast. But so we have a lot of time for discussion.
Thanks, Dr. Hansen. That was really insightful. We've got some questions coming in. I'm going to turn it over to Dr. Rizwanuddin, who's the head of Department of the Nuclear, Plasma, and Radiological Engineering, to moderate the discussion and pose the questions that are being put in the chat. And I'd encourage the other listeners to please post your questions in the chat as well.
Thank you very much, Madhu. As Madhu said, I'm Rizwanuddin, professor and head of the Department of Nuclear, Plasma, and Radiological Engineering. And thank you, Professor Hansen, for a very, very informative talk. I'm glad in some ways, actually, to see that the talk ended a little early. That will give us an opportunity to actually have a lot more discussion, which a topic like this deserves. And just to mention to the audience that this is the first part of a critical conversation that will continue tomorrow and day after tomorrow, in which these sort of contentious subjects are picked up, and then sides that represent different perspectives, they're all brought together. So I think the Q&A is going to be very interesting and lively. We will go ahead, please, go ahead and start entering your questions. I will start with the question of my own, which will hopefully set maybe the tone for the rest of the this seminar. What steps can be taken to bridge the gap between those who see nuclear as a viable source of carbon-free energy and those who consider the risk or cost to be too high? I mean, we have seen these two sort of separate echo chambers developing, and there is little crosstalk. Once in a while, somebody will switch from one side to the other, but there are strong opinions. So, Professor Hansen, do you have, based on your experience?
Yeah, I would say at least a couple things. One thing is, let's say we do not, it was assumed when President Eisenhower proposed atoms for peace, and that there would be global cooperation to assure that nuclear energy was used in a safe way. It was assumed, he assumed that the United States would be a leader and would be a technology leader. Let's say we decide, oh, we don't want to do this the way some people have suggested. Well, nuclear energy is not going to go away. We would be ceding the leadership to Russia and maybe China eventually. And they would be very happy to do that. And would the world be a safer place if Russia is basically determining what nuclear power plants are being built around the world, and what their safety standards are, and what the protocols are for assuring that none of the material is related to weapons use? I don't think so. It's not a choice. We cannot go back. You cannot put the genie back in the bottle. Nuclear power is here to stay. And we would be much better off if the United States had a voice, should have the leading voice in determining this international cooperation. But the other, that's one comment. We don't want to give the leadership to those nations. The other thing is, look at the history. I gave you the example of nuclear waste. Nuclear waste is not harming people, but the waste from other energies actually has a much worse record, even waste of things like solar panels. We have not yet figured out a way to make sure that the recycling of solar panels does not end up as waste in low-income communities and low and developing countries where we're sending the broken panels, which contain cadmium and chromium and other toxic materials. So it's actually some of the strong points of nuclear have been cast as being problems, while they're less of a problem. Every energy source has problems that you have to be careful and deal with, and they're actually potentially less with nuclear power. And we just have not done a good job of communicating that. But I'm encouraged by things like on one of my communications on my website, I point out this organization of these young women in nuclear energy. And they're doing a good job of communicating. You know, we have not, as nuclear engineers have not always been as good at communicating with the public. But I think there's progress in that direction, and we need to make more of that.
Thanks. You might have actually talked about a little bit, about the next question that I'm going to pose to you from one of the audience. That is about actually what if the similar amount of investment that we are expecting the government to put in nuclear, if that investment was made in solar, would that not yield better dividends?
No, you know, if you look at the huge subsidies that have been given to different energy sources, the International Monetary Fund estimated a couple of years ago that the annual subsidies for fossil fuels, about $5 trillion a year, with China giving the largest subsidies and the United States next. I'm not sure which the third one. I think Russia was third, but in the United States, it was about $750 billion. But the largest subsidies per unit energy are going to renewable energies. So people think that the government is really helping nuclear. Well, it's not economically helping nuclear nearly as much as it's helping fossil fuels and renewable energies. And you know, that's really the problem. What we need, if we're going to solve the climate problem, we need essentially all the players, and that includes nuclear. But we would need to be more aggressive than we are. At least the current administration is now saying, well, nuclear is part of the story, but it's not doing much to speed that up. You know, we should do like, well, Sweden was a good example. They decided, and they were going to move off of fossil fuels so they wouldn't be dependent on Russia or the Middle East. And so they had a plan, and that worked out very well. They built 10 nuclear power plants. Well, we're not quite at that point because, you know, it's been 3 decades since Bill Clinton, in his first State of the Union message, said, oh, we're eliminating this unnecessary R&D in nuclear power. We don't need nuclear power. Well, at the same time, we decided to give an unlimited subsidy to renewable energies by means of renewable portfolio standards. It's almost impossible to calculate how much subsidy that is because it doesn't appear explicitly. the ratepayer, the utility gets part of its energy from renewables, and the added cost is passed on to the customer. And we just and that worked. You know, it drove the price of renewable energies down. They're now cheap enough to be a major contributor to our future energy needs. But we should have done the same for nuclear. We should have said renewable, we should have said clean energy portfolio standards. Not, we shouldn't have, we should let the market decide and utilities decide what is the most economically efficient way, and let all of the clean energies contribute. But instead, we made a political decision that only renewable energies would be allowed. And that was a foolish decision, because although it works for a small fraction, for a fraction of the electricity, it gets harder and harder to add renewables as their fraction of the total electricity increases. They need to be complemented by a reliable baseload energy source that's dispatchable and available 24/7. And that's happening. What is it? It's gas. And gas is just about as bad as coal. It's not only producing CO2, it's producing methane, and it's polluting the groundwater, including places around here in Pennsylvania, which is a terrible shame, because we're leaving, if we go down that route, that we let gas be the complement to nuclear, get to renewables, then we've given our children and grandchildren a situation that's probably out of their control. We're just not going to be able to get climate. As I indicated in my talk, we actually have to cool off the planet. Otherwise, our shorelines are going to be changing. And I guess I failed to mention in my talk what the real threat is. You know, you hear in the media about now the politicians have these big words, existential threat. Well, climate change is an existential threat if we continue down the fossil fuel path. And how is that? It's because low latitudes are becoming uncomfortable, and they're going to even become uninhabitable if we stay on business as usual. It just becomes too warm, too humid for the human body to function outside. So that's already beginning to cause an immigration problem. We noticed that from Syria in the past decade because of the prolonged drought there, and the conflicts that are possibly even partly related to climate change, and immigration from Honduras because they got hit twice by super hurricanes, and it's just made such a hopeless situation there that people are just bailing out, risking their lives to try to immigrate to the United States. But if you combine climate immigration of that sort with the immigration from sea level rise, with nations like Bangladesh, which would be almost totally underwater, it will become an ungovernable planet. We'll be getting more and more governments under strong men it's every man for himself. That's the existential threat. What we need, on the other hand, if we can bring this climate under control and get energy sources that do not produce greenhouse gases and are affordable, we can continue to raise the standards of living. Because if you look at the recent history over the last several decades, you see that standards of living in many places were rising. China is a good example. Hundreds of millions of people were raised from poverty into middle class. And we could continue on that path. That path requires abundant, affordable energy. And China chose the path of coal. And while we chose the path, it's the same path. And so did the United Kingdom and Germany in the Industrial Revolution. Well, that's a path which is not sustainable. It's actually going to create this existential threat of an ungovernable planet. So we've got to find affordable, clean, carbon-free energy. And boy, we just don't see that many opportunities. Modern nuclear power is potentially a tremendously important contributor to that goal. And I can see us getting on a path with carbon emissions going down and with us saving the future for young people. But boy, it's also possible to imagine a path where we just continue to use fossil fuels, because these countries are going to give highest priority to their, as I started out my talk, the economics, the prosperity is the highest priority.
Yeah, so that's a good
for these
point,
countries, and you can't blame them for that. So there has to be an alternative to coal. It's so easy to dig coal out of the ground, or oil you can get out of the ground in Saudi Arabia for $5 a barrel. So they're going to keep selling that if we don't have an alternative.
So the question, that the last point that you raised actually about economics. So can you elaborate on that? The current state of how nuclear competes economically, and maybe tied together with the advanced reactors. So I can combine two questions.
Yeah, well, there's no good reason. So the requirement is going to be that nuclear has to compete with fossil fuels on price. And right now it doesn't. But there's no reason why it shouldn't. If you look at the price of the fuel, it's a small fraction. It's a tiny fraction of the price of nuclear energy. And if you look at the amount of material that goes into construction of a nuclear power plant, even the rather the generation 3 plus, the current large nuclear power plants that they build, you look at the amount of concrete and steel and material that goes into it, it's not that much. Compared with windmills or solar panels, it's actually much less for nuclear power per unit energy. There's no good reason why we can't make nuclear affordable and as cheap as fossil fuels. But it probably requires governments to want that. Now, we have a history, I'm sorry to say, of often appointing Nuclear Regulatory Commission commissioners, directors who are treating nuclear power as a caretaker, as though, well, we just want to make sure these nuclear power plants are safe, and that's and we'll probably phase them out. That's not helpful. We really need to recognize that we need to support nuclear energy the same way we support renewable energy. We need to find ways to make it inexpensive. We did a good job on the last 20 to 30 years of supporting the development of renewable energies, but we neglected nuclear power. And now it's put our young people in a dangerous situation where they don't have alternatives to fossil fuels as the complement to renewable energies.
So you talked about history. So one of the questions that is on the mind of many people is that there's some history of a deficit of trust between the nuclear industry and a segment of the population.
Yep.
What can be done to regain that trust, or what should be done? Any ideas?
Yeah, that's the big problem, and it, as I indicated on one of my charts, we really have to be very open and involve the public. There's some examples of where this has worked. You can't just impose this. We don't. There are countries, Finland, and even in South Korea, where the leader is anti-nuclear. A woman, I can't remember her name, but she had promised to close down the nuclear power plants, but they have an interesting democracy in South Korea, where they had a citizens group listen to the arguments, the discussion, the case for keeping nuclear power plants open or closing them. And it actually turned out that this group was drawn from the population, people with all different levels of education and experience. And it turned out that after they heard the arguments and heard the honest discussion of the merits and demerits of nuclear, they decided to keep the nuclear power plants. But there is so much disinformation. It's very difficult because, as I said, I'm not a Democrat or Republican. I'm not a liberal or conservative. But the liberal media, the conservatives do have a point that our media has become quite liberal, and they have perspectives, and they mischaracterize nuclear energy. They made the worst accident that you can imagine is probably the Fukushima type accident, where we need technology where that wouldn't happen. We need future technology that would not actually have caused that problem, which shut down and not require external power for cooling the fuel. But nevertheless, even the accident as it was greatly mischaracterized by the media. They made it sound like the nuclear was the problem. It was a tsunami that was the problem that killed tens of thousands of people. The public is also misinformed about radiation. Extreme radiation is certainly a problem, but low-level radiation is the fears of that are greatly exaggerated. It's amazing when you compare that with the concerns about air pollution, which kills thousands of people per day. You know, if we had a nuclear accident that killed as many people as air pollution kills in one day, we would shut down all the nuclear plants. It's just the public is just not well informed. And so that's a problem which we need to be do a better job. But you know, I find that young people are much more receptive to the merits of nuclear power. So I'm optimistic that when we have some good examples of the next generation nuclear, that we will get more support for that. But it's not easy. I don't claim to have this, have a good answer for how to solve this communication problem.
Thanks. Do you want to comment on some comparison between, you know, biomass and solar on one side and nuclear on the other?
Well, I think that's a local decision. You know, as I say, all energy sources have an environmental footprint. The footprint of solar and wind on a physical scale, on a scale of how big they are, is actually much larger than nuclear power plants. But that's the kind of thing which needs to be honestly described, and the public make their choices. I think that in many cases, nuclear will do very well in such a comparison.
Good. What about, so all you know, sources of energy have their own risk. And some people consider that, you know, some have a disproportionate amount of risk posed to some segments of population. That is, the risk is not equitably distributed. Are you aware of any study where this equity distribution of risk of different sources of energy is studied? And what do you think where nuclear stands on this?
Well, I think there's a lot of truth in the concern that low income, certain segments of the population have borne a greater burden, a greater portion of the problems, and gained less of the benefits. In the case of nuclear, much of the nuclear problems are actually associated with the weapons production and the mining for material for weapons rather than nuclear power plants. But even that there was some careless dealing with the waste in the mining, so that it affected Native American communities, for example. There's no reason that needs to be a problem on the long run. You know, if we want to, we can get all of our nuclear fuel from the ocean. We know how to do that. It's more expensive than uranium is cheap right now. mined uranium. So it's not much incentive to sieve it out of the ocean. But we could do that. If they're not going to clean up their mining and do it in a way that's acceptable, then we could say, let's just get our fuel from the ocean. But nuclear is potentially, is I see, not as any having a adverse effect on low income or minority communities. There's no reason that it should. You know, what's happened in practice is those pollution sources tend to be located in low income communities. It may actually work because the pollution source came first, and that made the property less desirable in that neighborhood. And so who's going to be willing to live there? Well, low income people. But I think that this actually should be a strong point of nuclear. I don't see that it needs to have any long-term effects that are class dependent.
One other question that came up was, related to China. China is going full speed ahead with all the renewables plus nuclear, and even with advanced nuclear. Where do you see U.S. and China relationship at the way they are evolving today in the context of the future of nuclear? Are we expected at some point to, import nuclear reactors from China?
Well, I hope not. I think that we should work together with them. You know, I've organized workshops at the East-West Center in Hawaii. Then the first ones were on climate and air pollution. But, when I realized that the path we were on with fossil fuels and not developing nuclear, I organized a workshop with a colleague in China, which initially I was going to have at the East-West Center, but decided I took the proposal of my Chinese colleague to have it in China instead. That way I didn't have to raise so much money to support the travel of workshop people. And we could see, we each have something to offer. The United States and China each have something to offer to this problem. We still have the best innovative capabilities in the US with our universities and just our culture. And we have a lot of good ideas right now for making modern nuclear reactors. But China and India have the great need for increased energy and replacement of coal if we're going to solve the climate problem. They're getting like 80% of their energy from coal. So there's the market drive there. So we should figure out a way. We should work together. And China wants to work. They consider our safety standards to be the gold standard. And they, even in a country like China, where the government has control of the major decisions about energy, they still have to be concerned about the population accepting nuclear power, because they do hear about the accident in Japan and have concerns about the safety. So there's benefits for both of us to work together. We have to drive the price down so that it's as cheap as fossil fuels. And we could do that if we work together. That's what happened with renewables. You know, it was, so we have to have some agreement on intellectual property rights and how we're going to share the benefits of cooperation, but it doesn't make sense to just ignore the thing. We can't, as I mentioned in my talk, we're in the same boat. We're going to suffer the same consequences of climate change if we don't cooperate. So I think that, and this is a point which is difficult in the United States, because the political parties have sort of decided that they have to sound like they're strong against China. They don't want to seem weak, and they're afraid they'll lose the election. But we have to have a broad understanding of what is needed. And what is in our best interest in the long run. And I think cooperation with China is in both of our interests.
So if I gather correctly, I mean, there are three things that we usually talk about, that are issues with nuclear, the safety issues that is at least, some segment of population, some considers that to be a concern. Then there is the spent fuel or waste issue. And then the third is economics. So do I gather it correctly that you consider the third one, the economics, to be the main concern? And what is your crystal ball showing at this point? Do you think that nuclear industry and the advanced reactor is on the right path to address that econ issue?
I didn't quite understand the last sentence or two.
So the question was, is the industry and the support from the government, are they on the right path to make
well,
economic?
The path is a lot better now than it has been in the last few decades. But it doesn't have the degree of urgency or level of support that's needed. I do, things are improving. I see we're getting more students in nuclear engineering. And the Department of Energy is supporting a couple of modular reactor types. And so things are moving, but they're going to take so many years. And the climate problem is going to put pressure on. We really need to move faster with the nuclear. And the problem is we just haven't had the advocacy. The Democratic Party has never been supportive. They're now becoming modestly supportive. And the Republican Party is basically a fossil fuel party. They think nuclear is good, and they will support it, but it's not the thing that's driving them, because the fossil fuel industry is, I'm a resident of Pennsylvania, and I see all the time what the fossil fuel industry is doing. I get these advertisements criticizing nuclear and saying, stop supporting nuclear don't allow a subsidy for nuclear. And then on small print at the bottom, it says paid for by American Petroleum Institute. So so fossil fuel industry has been an opponent, a silent behind the scenes opponent of nuclear energy. And even some of the big green organizations that have opposed nuclear power, a good part of their reason is that they're getting money from the fossil fuel industry. So it's a problem, but the indications are now moving in the right direction. We just need to get them to move fast enough. We need to get some of these examples of modern nuclear working, and I think and drive the cost down. But that's why it would be helpful to have a larger market to drive the price down. And that's why cooperation with those nations that have a huge need, like India and China, would make sense.
Good, thanks. So maybe I'll make this the last question. So this is a broader question, sort of maybe away from nuclear, although nuclear may be a part of the answer. But how do you get business and Wall Street to actually respond to crises that appear on a very different time scale, much longer time scale than businesses are used to? The time scale for Wall Street is a quarter. Is it going to be government policies, regulations? What do you think is the best mix?
Yeah, that's a really good question, because that's the problem. We don't have that investment in nuclear. And the reason is that they see the time scale as being so long. And that's the reason why we need the support to get the time scale as short as possible. That would encourage the investment. But the investors, it's just that nuclear is almost invisible. You don't hear. Well, it came up during the presidential debates, during the primaries. There were a few people who came out saying we really needed modern nuclear. But it's just, it has not got the level of supposed to move faster and to get money invested. There's this one startup that's going to build their ship-based reactor it's to be deployed in Indonesia. I'm not sure if it's going to be built in South Korea. That's Thorcon is the name of the company. But, they had been waiting to get an investment. They finally got $10 million investment. So they're moving forward and hiring engineers and things. But it's so little investment that's been a holdup that's prevented some of these startup companies from making faster progress. If we just get that moving a little faster, then there's plenty of investment money out there. And we just need to get some of it directed into nuclear, and we could really make a faster progress. So I don't really have a good answer to your question, but that is a big issue.
Okay, thank you very much. That was the last question. I would like to, on behalf of the Department of Nuclear Plasma Radiological Engineering, I would like to thank you. And I would like to pass it back to Dr. Khanna for some closing remarks.
Thanks, Rizwan. And thank you, Dr. Hansen. That was a really insightful talk and wonderful to hear such a broad perspective based on your long experience, both addressing climate change and looking at solutions and policies to it. So I think this was, we had a pretty diverse audience today, and you covered a really broad set of issues. So thank you for spending time this afternoon talking with us. I'd also, before we close, I'd also like to again thank the Baum Family Fund for supporting this event. This event was part of the Critical Conversations workshop that IC organizes every year. And this year we've organized one on the role of nuclear in a clean energy future. We're going to be, we have invited a diverse set of stakeholders that will be spending 2 half days tomorrow and day after drilling down on this diverse set of issues that have been raised with regards to nuclear energy, and sharing their perspectives. And we hope to come away with better understanding of these different perspectives and what we might do to move towards a common understanding of the strengths and issues related to nuclear energy as we try to look at a portfolio of energy sources for meeting the challenges of climate change. I'd also like to thank the Department of Nuclear Plasma and Radiological Engineering, in particular, Dr. Radin, Dr. Katie Huff, Caleb Brooks, Jim Stubbin, and also our visiting Levnik resident scholar, Dr. Dania Jokic, who've been helping to organize this event and make this possible. So we will, at the end of our 2-day workshop, we will be putting together a summary document and making that available through the IC website. And I'd invite you to take a look at that. So we hope to continue this conversation in the future. And I thank you all for attending today's event.
Yeah, if I can make a final comment, I'd like to thank you for doing this, because I think we need more of this from more universities and get more young people into this field. And I think that would be enormously beneficial for climate and for the future of young people and nature. So thanks a lot.
Thank you.